When I did this last time, we did about 3 hours, and I'm going to shoot for 2.5 hours today. What I want to do, and the VC and the Google Doc Q&A is going to make it a little challenging, but I want to try to make it less lecture and more interactive. And so last time it was about 2 hours of lecture and an hour of interactive. And so I'll do hour and a half of lecture today. But through that, I want you to stop me with questions. And so since we're doing that through a Google Doc, that's going to be kind of hard. So Rick, if I encourage you, I guess questions have gone in there ahead of time, but I encourage you, if you have a question about the thing I'm talking about right now, I don't have the Google Doc open here, put those in there and say like urgent or now or something like that, so that it's not a question for us to take at the end. I'd rather have questions come in when we're talking about that topic, actively in the slides. So I wanted to be more interactive. We'll do an hour and a half of lecture, take a little break, and then the last part will be some live analysis of 4 of the websites that are represented here today. I analyzed about a dozen of them and picked the 4 that were slowest to look at. So you'll have the suspense of knowing if you're one of those 4 websites until the hour and a half mark. And my overall goals today are, people aren't necessarily aware of the area of web performance from a user's perspective, so I want to kind of highlight that. And then I want to talk about, do very hands-on. I find that once people touch stuff and they actually fire up a tool or do some kind of analysis, then they're much more likely to go back and do that on their own after this workshop. So I want to try to I'm going to switch over to the browser a lot during the presentation, and hopefully you guys will too out in the audience. I think all the tools and URLs will be pretty self-evident, but if not, again, I guess through the Google Doc, please try to let me know about that. And so we'll get familiar with tools and some best practices, but we're going to start with a little background on me and then background on why speed matters. So this is the story of my life. I take slow things and make them fast. When I was in 8th grade, we studied the Industrial Revolution, and I thought the best job in the world would be one of those efficiency experts who figured out how to get children to be more productive on factory manufacturing lines. And so now I'm the current equivalent of that. I'm figuring out how to make the internet more efficient. So I was at Yahoo for 8 years. My last role there was the Chief Performance Yahoo. I'm at Google. I'm the head performance engineer here. I've been here now 5 years. Almost all my work is open source. Probably the biggest open source project I did was YSlow, but I've also done Gazillion, SpriteMe, BrowserScope, JDrop, and HTTP Archive, and we'll look at some of those today, or you can just Google them and find them. I wrote these 2 books on web performance that are kind of considered the Bibles, and they're very thin, and so they're easy to read. I encourage you to check them out. I taught at Stanford based on the books, and I teamed up with O'Reilly about 5 years ago and started a conference around this space. And now we're in China, Europe. We're going on our 6th year here in the US, and I think we're going to roll out another location this year. So that's going really well. So this space is taking off. And to me, it was obvious when I first discovered what was going on and how browsers work and how users experience the internet that this was going to take off. I've been doing this stuff for about 8 years now. And when I was at Yahoo, I knew I wanted to be at Google. And so I was really excited 5 years ago when the recruiter contacted me, because Google has, Yahoo is an awesome company. The execs there were totally, incredibly supportive of the exceptional performance team I started there. But everyone at Google cares about performance. And that's even in our 10 core principles. Number 3, I don't necessarily know if they're prioritized, is fast is better than slow, and we continue to work on making it all go even faster. So at Google, the philosophy I have, the mentality I have on performance and efficiency and speed resonates with everyone in the company, developers and beyond. And so it's really a great place to work because everyone is on the same page. So certainly Google is on the bus when it comes to faster websites. But there are a bunch of other case studies and examples that I want to highlight. So here's Fred Wilson, probably the #1 VC out of New York City, speaking at a tech conference on his 10 golden principles of successful web apps. And guess what the principle #1 is? Speed. First and foremost, we believe that speed is more than a feature. Speed is the most important feature. And he goes on to talk about how for their portfolio companies, they track them, their website speed, and there is no doubt in their mind that when the website starts slowing down, the business starts slowing down. And so that's why they feel that making the website fast, making the user experience efficient and pleasurable is good for the business. And they're not the only ones. There are a lot of other examples that have data behind them. So this is a talk where Bing and Google Search got on stage at Velocity a couple of years ago, and they had both run very similar experiments where they put a delay in the search results page and saw how that slowdown, making the search results slower, impacted the user experience and the user metrics. And so here we see Bing took it up to a 2-second delay, and perhaps most relevant, they saw a 4% drop off in revenue per user. Google took it up to 400 milliseconds, and they saw a 0.59 drop off in searches per user, which is basically the same as revenue. And so that's a pretty small percentage, but at Google scale, it's still a significant revenue impact. And so performance is important for search. Yahoo did a similar experiment a little bit later, and they saw a 5 to 9% drop in full page traffic. Here's other examples. This is Mozilla. So when you are downloading Firefox, you go to what they call the landing page, depending on what browser you're coming from. So if you're coming from IE, you go to a certain landing page. So for that landing page for IE, they made it 2.2 seconds faster, and they saw a 15% increase in download conversions. So for them, that's their business metric, and they saw a tremendous impact by making the website faster. This is a seminal study from a couple years ago from Shopzilla, where they made their site quite a bit faster. They went from 7 seconds to 3 seconds on average, and they saw a 7 to 12% increase in conversions. This fourth stat is really critical. They doubled the number of unique users coming in through search engine marketing. And this was the first study that talked about the impact of performance, of these performance best practices on operating costs. So for them, they cut their hardware costs in half by adding these performance optimizations. And that's pretty logical. For example, one of the optimizations that we'll touch on in a minute is adding an expires header so that instead of users having, instead of users having to download resources every time they go to your page or hit your server and at least check if those resources have changed, they can just read them off disk for a longer period of time, a week, a month, maybe a year. And so you can imagine the average page has about 80 or 90 requests in it. If those 80 and 90 have to be checked every time versus only once a month, that's going to dramatically bring down the load on your servers. And so you can see hardware reductions like this. And this is pretty typical. I get stats like this quite often from people out there. Here's another one from a buddy of mine when he was at Netflix, where for some reason they didn't have compression turned on. They'd had a bad experience years before with an old version of IE without Service Pack 1, and so they had turned it off for years and years and years. And finally he said, hey, let's get agreement, let's turn it back on. And one day he turned it on, and you can see they cut the outbound traffic from their data center in half. So for them, this is probably 6 figures a month in dollar savings that they have. Here's another similar cost savings. Guy who spoke here from Edmunds.com rolled out a new kind of side site and he wanted to try to instill in the dev team and the execs this desire to make the website fast. So he picked a very easy optimization. It only took him a day or two to implement, which was adding an expires header. And this cut their traffic to their CDN by 34%. So again, you can imagine for a site this size, they're probably paying 6 figures a month for CDN usage. If you cut that by a third, that cost by a third, it's very significant for a very small change that can be implemented quickly. And about a year and a half, maybe 2 years ago now, Google announced that we were going to take site speed into account when it came to search ranking. So of course, this is what SEO is all about, getting your site as high up in the results as possible. So speed is now critical when it comes to SEO. So all of these things have come together and formed what I think is an emerging industry. And so I named it WPO, Web Performance Optimization. And that's pretty much stuck. I did that in a blog post about 2 years ago, and most of the companies in the space, whereas 2 years ago we had maybe a handful, there's now dozens of companies working on WPO, and there's a lot of M&A activity there as well. And the elevator pitch is it drives traffic to your site. We can see that with PageRank or with, for example, Shopzilla's stats about search engine marketing doubling unique users. It improves the user experience. We see that with those user metrics from sites like Google Search and Bing about users staying longer, doing more page views, better conversion rates, increases revenue, again, better conversion rates. Shopzilla has an increase, and it reduces operating costs. And I think we're going to see more studies that quantify this. I think this is a significant savings. And there haven't been that many studies. I've talked with a couple folks about quantifying the green side of this. So definitely when you reduce hardware, not just on the server side, but also on the client, when you reduce hardware and power consumption, there's savings in carbon emissions as well. So there's a green side to this. Web performance optimization as well. So hopefully at this point, we're all on the same page that fast is better. It's not just better, we all know, I think, for those of us who are developers, it's kind of part of our DNA to have code that we know is fast and optimized. That's something that we like to be able to brag about. But now we've seen from these case studies that this carries over to other organizations within the business, sales, marketing, business development, that there are other correlated savings when it comes to business metrics by making the website faster. Oh, and I just got one last night. I tweeted last night. The Obama campaign used a lot of the tools and techniques that I'll be talking about to improve the website for accepting donations. And they improved the speed of the website they reduced the time by 60%, and they saw a 14% lift in donation conversions. So another case study that's very timely. Okay, so that was part one, fast is good. Now I talk about web performance. What exactly do I mean by performance? I get a lot of emails from hiring people and advertising people who think performance is related to performance of employees or advertising, and I'm talking about web performance. So what do I mean by that? So when I think of performance, I think it falls into two main camps, efficiency and speed. And I'm talking about the speed part. So the efficiency part is really important, and in fact, I think it's more important for a company that's just starting off. The efficiency part is the part that's going to let you grow your user base by 10x and not have the site fall over. And so efficiency is really, really important. But if what you're after is a faster user experience, then you actually have to look somewhere else. So when we look at efficiency, we look at what's happening on the back end, because that's the hardware that we control. And what I discovered 7 years ago, when I first started working in this space, was I fired up a packet sniffer. So hopefully all of us are familiar with the chart that I'm showing here in this slide. It's called a waterfall chart. Each horizontal bar is an HTTP request for some kind of resource. The first one is for the HTML document, obviously, and the rest are for images, scripts, style sheets, Flash, other things. And in this particular view, the colors represent different states of the connection: a DNS lookup, establishing a TCP connection, downloading the actual content. And so what we see is the place where our backend is doing the most work, stitching together that HTML document, doing all the RPCs to pull in this user's settings, their friends, their blog posts or whatever, that really only accounts for a very small part of the overall time that the user is waiting for. The green line in this, the green vertical line in this chart is when the page starts to render, and the blue line at the very end is the window onload event. So the user is waiting at least for the page to render, and potentially for the images that they're looking for to be rendered on the page. And the time that we're spending on the back end is a very small percentage of that. And so I call that the back end time. All the rest of it I call the front end time. Some people, they break this into three main categories: back end time, front end time, or client side, and network time. But you'll see in a minute I'll talk about why I lumped the network time into here. And the high level reason is that there's a lot that you can do in how you construct your page and how you construct your resources that can dramatically reduce the network time. So I don't want us as developers to think the network is something that we don't control. I remember the very first team that I ever consulted with 7 years ago to improve the speed of their site said, well, what can we do? We don't control their network connection. We can't give everyone a DSL connection. Back then, people were still predominantly dial-up at home. And it turned out we were able to make that website twice as fast without changing the user's network settings at all. So when I talk about performance, I'm talking about how long the user is waiting to engage with that website, to engage with that page. And what we see here is the long pole in the tent is that front end time. And so to really hammer this home, I tell people you could reduce the back end time to 0, and most people wouldn't notice because it's a very small percentage of the overall experience. Now this is just one example. I think this is Google search. I'm not sure. But I've got other data here. I run this project called the HTTP Archive, where I collect performance data on the top few 100,000 websites in the world. And here, if I look at the top 10 websites in the world, about 27% of their time is on the back end, right? So, it's a higher percentage than we saw in that last waterfall chart. But let's look a little deeper. If we go to the top 1,000, which is still a very small number, if you can get your website in the top 1,000 worldwide, that's incredible. And it's quite a jump. It goes from 27% on back end to 17%. The reason for this is those top 10 sites are highly optimized. They have very few requests. So the average website has about 80 or 90 HTTP requests in it. The top 10 has an average of about 25 or 30. So the time for the HTML document, that backend time, is just going to be a higher percentage because the size of the pie is much smaller. The number of HTTP requests is much smaller. So the top 10 will also have faster onload times than other websites. So what we see here is even though we're not very far down the tail, we're still in the top 1,000. The sites have gotten much bigger. The focus on performance on these front end, a lot of the top 10 sites have already done these performance optimizations that I'll be talking about, or they've done a majority of them. And so they're already optimized. Even in the top 1,000, there are a majority of sites that don't have the basic optimizations, performance optimizations deployed. So we see 17% of the time is on the back end. So it's here, obviously, again, the front end time. The network and what the client is doing is the long pole in the tent. And if we go even farther, if we look at the top 100,000, it drops, the back end time drops even more. So the point here is that the front end time is really, really important. And to bring this home, I looked at the sites for the URLs that the folks submitted when they signed in. And on average, the back-end time is less than 9% for the sites that are enrolled in this Startup U University session today. So if you want to make the website faster, you got to focus on what's happening in the browser. Making the back end faster might help you if you increase users, if you're storing more data, but it's not going to help if you want to make the user experience faster. And again, you could drop that back end time to 0, and most people wouldn't notice. So that's, I think, the biggest contribution I've made to this space. I call it the performance golden rule. 80 for almost all the websites I've ever looked at for the last 8 years, this holds true. 80 to 90% of the time the user is waiting is spent on the front end. If you want to make the website faster, you got to start there. There's a greater potential a priori probability of making an impact. If you could cut the back end time in half, you might only shave 5 or 10%. If you can cut the front end time in half, you can shave 40 to 50%. The changes are simpler. In that Edmunds.com example, I explained how they just in a couple days rolled out a far future expires header, and they cut traffic through their CDN by a third. So these changes are typically much simpler than what you would do on the back end, like optimizing a database or rolling out more servers, replicating your data center across multiple locations. And they've been proven to work. So I've been doing this a long time. The websites that I have worked with have seen tremendous gains with a relatively small amount of investment of work. So, okay. So then, trying to define performance, I wanted to quick talk about metrics. So let's look at what I think are the 4 most important metrics that you can quantify when it comes to performance, the speed aspect of performance. So suppose you do a Google search and you get a link to my website and you click on it. So what's going to happen is that's going to send a request to my website for an HTML document, and the first packet of that response is going to come back. And it's really interesting. I talk in a minute about the tail wagging the dog. Browsers from IE6, maybe even earlier, but for the last 10 years, realized that it's better, even though you click on a link, it's better to leave the current page visible than to clear it waiting for the next page to come. So what happens is when you click a link, suppose my server is actually really slow, you'll still stare at the Google page. It won't be erased. But once the first byte of that HTML document response comes back, then the browser is cleared. So this is what happens. You click a link, and the time to first byte, the first byte of that HTML document comes back, the screen is going to clear, right? So that's a really important metric. That's basically going to tell you your break between the back-end time and the front-end time. For some websites, this time to first byte is really long, and then you should focus on the back-end database or whatever, server software. But most of the time, this is about 10 to 20% of the overall time. But that's important to look at. Then the next one is start render. So depending on what's going on in your page, and we'll talk about that in a minute, you're going to have a period of time where the screen is just blank white, and then the browser starts parsing the HTML and drawing things on the page. And that white time is a really disturbing time for the user experience because the user doesn't know what's going on. They don't know if there's an error, if the server's never going to respond. They're kind of in this limbo, and that's where you'll see a lot of abandonment. They'll abandon the page and go to some other website, or they'll hit reload, which just exacerbates the problem because if it was slow before, it's probably going to be slow again. So this time to start render, this is really important from the user experience perspective because it gives the user feedback that you're actually responding to their requests and doing something about it. And then we have above the fold time. So many web pages, most websites have content that goes below the fold. But from the user's perspective, they are going to feel like they're ready to engage with the site when the content above the fold, the visible content in the screen, is visible. And so that's a really important time. Now, unfortunately, the start render time and the above the fold time are not easy to measure. In fact, there's no way in a standard browser that you can do that today without some kind of plugin. And then the time that we've used for the last decade to track web performance on the client side, speed, is the window on load time or the page load time. And so this is where everything in the page, even the stuff below the fold and all the requests you're doing at the end, are totally complete and the page is done rendering. You might have things like XHRs that are going on every second to check for updates or something like that. So it doesn't include that. It includes the time when all the content in the page is drawn and any last minute XHRs to update data in the background are done. So those are the 4 main milestones in tracking speed or web performance for your website. And by far, the window on load time is the one that's most used. This is kind of a holy grail topic in the world of web performance right now. In the world of Web 1.0, when it was load a page, load another page, load another page, window on, and there wasn't a lot of dynamic behavior in websites, the window on load time was a great proxy for the user experience, for the user perception of speed. But today, with single page web apps and a lot of AJAX going on, the window on load time is losing relevance more and more. So I wanted to highlight that in these next few slides. So the remote people are off the hook, but the local people are now going to be forced to interact. So in the tail wagging the dog context, here's the same page, my website, and these are hypothetical examples. I've taken screenshots every 2 seconds. So in scenario A and B, they both start off with a blank screen at 2 seconds. The screen's blank. In scenario A at 4 seconds, A and B at 4 seconds, we've started rendering. And now in scenario B, the page is done at 6 seconds. In scenario A, we've only rendered about half of the page. And then finally at 8 seconds, it's done rendering the entire page. So of these 2 scenarios, A and B, which do you think is better for the user and for your business? B. Okay? Anyone think A? Good. Okay. How about this scenario? A is better. Why? Yeah. In the other example, somewhere between 4 and 6 seconds. In B, the user's waiting somewhere between 4 and 6 seconds to get any feedback that the thing is working. And they might move on to some other site. At least in scenario A, sometime between 2 and 4 seconds, some feedback arrives and the page starts rendering. So A is better, right? Okay, how about this scenario? If we get unanimous decisions here, I'll be surprised. So everyone has to vote. Which one?
I say B.
B? What did you say? A? A? A. 3 to 1. Okay, I'm the performance guy. I would pick B here, right? Now, but it's a trade-off, right? Both of them, are, have pluses and minuses. So, why would you say A is better?
I thought users would stay a little bit longer to make the page to render if it's
Yeah.
it might be longer.
Yeah.
I think B would lead to more page refreshes.
Yeah. Okay, or I'll just repeat. So the answers were, with A, we're giving the user feedback sooner. At 4 seconds, the user has feedback, and so there'll be less abandonment. So that's a good thing. Why do you think B is better?
So I think B is better because while A may have quicker feedback, it still has a 2-second or a 1-second hang time, whereas B finishes a little faster.
Yeah, and to me, 2 seconds is kind of good. If the time values were different, maybe if it was 4, 8, 12, 16, I would feel differently. I kind of like that all the content is there 2 seconds earlier. Okay, so now what about this? What if instead of 8 seconds, It was 6.2 seconds. Does anyone think B is better? I don't think so. Because in A, we give the user feedback much sooner that the page is rendering. And even though they have to wait 200 milliseconds longer to see the full content, they got that reassuring feedback much earlier in the experience, so they're less likely to abandon the site. And also their perception of speed is going to be much better. I'm going to write a blog post maybe this weekend. I built up an example page that shows this, where you can, in this example page, you can reload it the way browsers work today, where it doesn't erase the page until the new content arrives, or it can erase the page as soon as you click on a link. And I can tell, and even though the arrival of the new page is the same in both examples, I can tell you the time where it erases the page as soon as you click on the link is so painful to sit through. It's amazing how staring at a page that you've already read everything on the page is so much more enjoyable than staring at a blank page. I'll digress and tell a great story. I'm actually going to do another paper on this. So it's all about perception here, right? And my degrees are in systems engineering, industrial engineering, and we were always kind of jealous of the CS guys. And so we had this story where this guy owns an office building, and all the tenants are really growing, and they're complaining because they have to wait for the elevator. And so the owner of the building calls in a civil engineer and says, what can we do? We've got these 2 elevators, the tenants are complaining. Civil engineer says, well, we can put in 2 more elevators. Structurally, architecturally, the building can support that. And the owner says, oh, cool, okay, so how much is that going to cost? He goes, well, it's going to cost about $5 million, and we'll have to close the building for 6 months. And the owner's like, wow, okay. So then he calls in a computer science engineer. And the CS guy says, yeah, well, I've been working on these AI algorithms lately, and I can actually write some machine learning algorithm that will look at how the tenants' patterns change during the week and during the day, and it will actually learn where to position the elevators to get the shortest wait time for anyone who pushes the button. And the guy's like, oh, well, that sounds pretty good. How much is that going to cost? Oh, it's going to take me about 6 months, and it'll cost about $300,000. Okay, well, that's a lot better than closing the building and spending $5 million. And then he calls in a systems engineer. The systems engineer listens and looks and says, TVs. We'll put a TV in every elevator lobby, and no one will ever complain again. And that's what they did, and it actually worked. Because the user is distracted, their perception of their wait time totally changes if they have something else, even something menial like watching even a terrible TV show. It changes their perception dramatically of what's going on. So the point of this example is there are actually some of these performance optimizations that could make the window onload time worse. But what they do is they improve the user's perception of the website speed by promoting rendering and making rendering happen earlier. But the hard thing about those is we can easily measure onload time. It's harder to measure these rendering times. So I want to talk a little bit about that when it comes to metrics, how to gather the data. And the big debate now is synthetic versus RUM. Really, the answer is synthetic and RUM. You need both of those. RUM is real user monitoring. So synthetic is basically kind of where people started and what maybe many of us are doing today. It's not real users, it's synthetic users. So it's our QA testers, it's our lab that we're running automated Selenium tests, it's other automated services that we're using. For example, Keynote, mostly, they do RUM, but they've built their best business on synthetic testing. They've got these pops in different locations, and they'll run some URL that you give them over and over and over again. Web page test we'll be talking about is a tool. There's a lot of coding platforms for building automated synthetic testing, Selenium, Water, etc. The pro of synthetic testing is you're eliminating a lot of variables. There are a lot of variables in live internet and real users, and you're eliminating those. And by eliminating those variables, by controlling those variables, as we know being scientists, is it makes it easier to isolate anomalies, the cause of anomalies. So if you're not taking into consideration users that have weird connections and funky hardware, if you're running on the same hardware from the same location on the same network over and over and over and over again, and you see a spike, you're more likely to be able to determine what caused that within the systems that you control. Do you have data center issues, hardware issues? Did it coincide with a software push, so it's a software issue? And the other plus, tying back to these rendering statistics, is because you own these PCs, you can add more instrumentation to them. You can add plugins that can measure things like these rendering statistics, how much memory is consumed, what the CPU profile is like. So you can get more deeper metrics on the performance of your website. RUM is metrics gathered from your real users, from the people who are hitting your site every day. It's typically done with JavaScript inside the browser. There are things that you can measure to see how fast it is in different parts. You can't use it to measure rendering as well. It's a little harder. There's nothing built in automatically. Examples of RUM, it's now built into Google Analytics. There's a tool, an open source JavaScript library called Boomerang from Yahoo. A company called LogNormal is the author of that. Torbit offers it. They're a web performance company we'll talk about later. I wrote some code called Episodes, which has been picked up by several performance companies, and they're using it because it's open source. And the pro of RUM data is that it does reflect these real world variables. You know, to be honest, it really doesn't matter that much if within some automated lab, the website is really fast, but the real users are having a terrible experience. And typically, in my experience, what I find in working with companies that have both of the synthetic and RUM data, the synthetic data portrays website speed that's about twice as fast as what real users are experiencing, sometimes 3 times as fast. And there's a couple blog posts from me and the folks at Etsy on that this week. And so I think it's important to capture both. The synthetic lets you isolate regressions in your system or anomalies in what you control. But the RUM lets you actually see it from the user's perspective, because there might be things that you haven't taken in consideration, different kinds of browsers, different kinds of network conditions that you can affect the performance on if you're aware of them. And so I think for companies that really care about performance, they need to run both. So I don't have examples of synthetic solutions, but I do have a couple examples of RUM solutions. So I'm going to see what happens if we go over here. Okay, cool. So let me make that a little smaller. So this is Google Analytics running on my website. Google Analytics runs on about 60% of the internet, so that's good. And about a year ago, we built, and so typically it's used for measuring impressions and conversions and stuff like that. And about a year ago, we added this timing intelligence to it. And so even if you haven't done anything, if you have Google Analytics in your website, not Urchin, ga.js, then you're getting these kinds of stats. So let's see, I can go to content, site speed, and I can look at this overview, and I can see my page load time. So I don't know why I had some spikes. I'm on my website's on some tiny shared DreamHost server. So this could be, maybe I had a spike in a popular blog post and it slowed down the server, or they throttled my processes somehow. You can get an average page load time. So for me, it's about 7 seconds. That's not great. And of course, you can do the typical Google Analytics thing and break it out by browser, by type of page. So this data, if you use Google Analytics, even if you've never configured anything around the speed stuff, you will have data in your Google Analytics dashboard right now. So I encourage you to go and check that out if you've never looked at it before. Now, by default, it throttles the number of data points it gathers to about 1% of traffic, or I think 10,000 data points a day. So if you're a smaller website, you can actually go in and you can up that to 10%, maybe even higher. So there's documentation you can look at on that. I mentioned another alternative, Log Normal. These are the guys that wrote the Boomerang code that they open sourced, but they rolled out a company on it, and they call it Log Normal, but they just got bought by Sosta a month or two ago. And so, you can see the UI is a little different. Here I can get a histogram. Histograms are actually the best way to look at performance data. I can get, red, yellow, green charts geographically. I can get, error plot over the last 30 days and do other similar types of drill down. And Torbert was another one I mentioned. And I have all three of these running on my website just so I can keep track of what the performance numbers look like. So here we can see it's quite a bit different. Here they have a median of about 2 seconds and an average about 4 seconds. So that seems quite a bit faster than what Google Analytics was reporting. So that's a little troubling. It would be good to go in and figure that out. The techniques that Torbert and Log Normal use are fairly similar. So here we see, I think this is median, 2.5. So that's pretty close. I don't know if these guys, Log Normal, even show an average. I think they look just at median, which is actually a better number to look at than average. But the technique that these guys use is a little different than the one Google Analytics uses. So that could be a cause for the differences in the measurements. So whichever you decide to use, if you have Google Analytics right now on your site, I recommend you go in and look at the charts, maybe increase the sampling rate if you have room to do that. If you're not using Google Analytics, you could add it, or you could look at some of these other solutions. So I think having RUM data is really important. Wow, that worked pretty well. Cool. So in the slide deck, I have slides for all three of those folks. Okay, so how are we doing? Oh, now the timer starts over. Okay, good. So let's talk about best practices for maybe 20 or 30 minutes. Can we go that long, or do you want to take a break now? Break? Okay, let's take let's see. Okay, I've got 10:51. Let's reconvene at 11, and we'll do best practices and maybe dive into a little bit of the interactive performance analysis. So see you guys back here in 9 minutes. And we are back. So turns out both books kind of accidentally that I wrote had 14 main rules or suggestions or optimizations. So this book was, High Performance Websites was written in 2006, 2007, really in the Web 1.0 world. So it's still really relevant, like if you don't understand how the expires header works or what e-tags are, which most developers don't, it's really good to read this. But rather than go through each of these, I think that's a little dry. I wanted to kind of highlight the mindset of the book based on these weird behavior patterns that I noticed, way back then in how browsers work. So I built this website called Kazillion, which is short for because there are a zillion things to test, which is generally true. I would find that I was writing all of these test pages to see what would happen if you did this before that or this after that. And it was much easier to create a test page creation harness. And so, this is open source and available to the public. So the thing I wanted to show here, and when we go back, what you'll see a lot of the rules have to do with is behavior like this. So suppose I have a script, And I can say how long I want it to have a delay. Like, let's just make this script, for example, take 5 seconds to download. And then I have something like an image in here. And we'll make this image take 0 seconds to download. All right. Now we can actually create this page and see what it looks like in the browser. So look, the page is blank. Now I can guarantee you the actual well, and in fact I don't have to guarantee you. Let's open up Chrome DevTools. So I'm on a MacBook. I'm going to do Command Control I. You can probably get to it from the, Command Option I. There we go. You can probably get to it through the menu as well. So, and I'm on the, I'm usually on the network panel, so we'll stay there. So let's load this page again and see what it looks like. So look, the HTML document is already done, but the page is blank. The HTML document that contains all this text, the word gazillion with the tagline, this is, I call it an avatar of the page. This is just, a div, with some borders and coloring and stuff. All of that is in the HTML document, which is downloaded like in 70 milliseconds. But we don't see anything for 5 seconds. Why is that? It's because, I'll close this now, all browsers today, and from when I started 8 years ago, will not render anything in the page until, will not render anything below a script tag until that script is done downloading and being parsed and executed, right? Now, most developers put their scripts in the head, which is above the body. So it means nothing in the page, because everything in the page is in the body, nothing in the page will be rendered until all the scripts in the head are downloaded. So in the book, I have this rule, put scripts at the bottom. So let's just do something simple. Let's put this at the bottom of the page and see what that change does to how this page works and what the user perception of speed is like. Now, I get all the stuff in the HTML that's above the script. I get that immediately, including this image that I put in there. So you can imagine if you put this right below the body, all your scripts, everything else in the page, all the images, all the text would be rendered immediately. And the same thing is true, let's clear this. This kind of similar behavior is true for style sheets. Here, I'll just leave that at 2 seconds. It'll be a little faster. Let's change the image, though, to 0. We'll create the page, blank, for 2 seconds. Everything below it is blocked from rendering. And now, a way we can get around this, we can move this down here. It'll render right away. And then the style sheet will be downloaded. If any of the styles apply, they will be applied. You might get a reflow and a flash of unstyled content. But at least you can get the stuff that's visible to the user loaded as quickly as possible. Unfortunately, even this hack doesn't work in Internet Explorer up through 9. I think they fixed it in 10. So even moving style sheets at the bottom won't help what is probably a majority of your users, or at least a significant percentage. So there's reasons, that's a longer discussion about why browsers are built this way, the challenges of painting when you still have JavaScript outstanding. But those are the kinds of insights that led me to start developing these best practices and blogging about it and writing about it and speaking about them, because they're fairly simple fixes, like moving scripts to the bottom of the page, that can improve performance. Here's another great one. I'm going to put 8 images into this page. Okay, now I'm going to open up the waterfall chart, and we'll create this page and see what happens. Each of these images takes 2 seconds to download. So what's going to happen? Oh, I think I have to resize this. There we go. Some of them took 4 seconds. And if we hover over, we see that the first 2 seconds for these is what's called blocking. It basically means nothing was done. The request wasn't made. So only 6 of them were done in what we would have expected to be the 2-second time frame. And because of this, the page loads in 4 seconds instead of 2 seconds. Why is that? It's because in most browsers, including Chrome, only 6 requests can happen in parallel for a given host name. And so we have 6 in parallel. These are all being done on 1.gazillion.com. I'm going to hide that information now just to give us better visibility. And so we have 3 of them, and as soon as one finishes, the other ones can start. So an easy fix for this is what's called domain sharding. Put them on a different domain. So I have another domain, domain 2, which is just 2.gazillion.com. And if I do this, instead of the page load time being 4 seconds like it was before, now when I create it, the page load time is 2 seconds. And that's because, if we go back to the network plot, all 8 of them are being downloaded in parallel. Well, there's a little bit of delay there. I wonder why that is. It just took waiting. Let's try it again. I don't know what was going on there. Yeah, there we go. They're all downloaded in 2 seconds, and so the page is faster. Now, here I was working with 8 images. The typical website has about 40 images on it, 40 to 50 images. Some of those might be coming from ads or other third-party widgets, Facebook or Plus One, images that you don't control, and they're on a different domain anyway. But if you have 20, 30 images from your website, all being downloaded in parallel, in the page, keep in mind only 6 of them at a time can be downloaded in parallel. And so you're going to get this stair-step pattern where 6, 6, 6, 6, 6. If the average image takes a second to download, it's going to take 5 seconds to get through those 30 images. Whereas if you shard them across 2 or more domains, you can cut that time by increasing parallelization. 2 domains is typically the correct number to balance with when doing domain sharding, because you also increase the number of DNS lookups that have to happen. So rather than go through a bunch of slides, I wanted to, okay, yeah. So when I started playing with browsers 8 years ago and looking at packet sniffers, these were the kind of weird performance issues that I found. And the workarounds are fairly straightforward. Today, a lot of the workarounds have been built into the browsers, but there are still a number of them, like domain sharding, that can be beneficial. I didn't want to do slides on all the rules, except for the first one, because this is still the most important rule for making websites faster, is reducing the number of HTTP requests. Now, that's kind of easy to do. The actual background plot here is, over the last 2 years, this is the increase in the size of websites. So it started off 2 years ago around 700K, and as of this month, it's up around 1.3 meg with 87 HTTP requests. So websites, the amount of content on websites continues to grow. And so this rule, and each HTTP request slows down the page and has overhead with it. And so the challenge is, it would be easy to reduce the number of HTTP requests by just stripping content off the page, but then you lose features, you lose maybe the look and feel that you want for your website. And so to me, the challenge is, can you reduce the number of HTTP requests without reducing the richness of the site? And the answer is yes, and we're going to talk about 3 techniques for doing that really quick. A simple one is just combining or concatenating your scripts and style sheets. I don't mean combining scripts with style sheets. The typical website has 7 or more external JavaScript files. The ones that you're hosting off your site, just concatenate them together. And you can turn 5 or 6 separate HTTP requests into 1 or 2 requests. Same thing with style sheets. And there's code out there that can help you with that. There's an Apache module, mod concat. And there's also something I worked on when I was at Yahoo, the combo handler. There's a description of it. And so you can do this programmatically as well. Either write your own or use these existing pieces of software to achieve this ability to reduce HTTP requests for the scripts and style sheets that you own. Concatenating them together in the order that they appear in the page already will produce the same behavior. So it's a very safe optimization. Another way to
So there's some questions on the web about, or on the shared doc, about how is moving scripts to the bottom better than an async script tag?
So the question was, how is moving scripts to the bottom better than an async tag? And I actually have a few slides about that in a minute, so we'll talk about that. Thanks, though. Definitely add more questions. I would like more questions as we go through, so add those.
I had a question about the DNS stuff.
Yeah?
You said domain sharding was best for 2 domains?
Yeah.
Because of the hit of DNS.
Yeah.
What if you have multiple pages? Do you still get that? You know, if I did 6 domains, is that a one-time hit or?
For the DNS lookup?
Yeah.
It depends. Your DNS lookup will have a TTL, but I wrote in fact, in the book about domain sharding, it talks about this. It's kind of funny how DNS TTLs are treated. For example, some browsers, even though your TTL might be 5 minutes, if you visit that domain at least once every 15 minutes, it will never expire the DNS resolution. And so this is why, for those of us that run data centers, you might want to shut down your East Coast data center, and you'll have turned off that DNS lookup that points to that data center, and hours later you'll still have people submitting requests to it. And it's because that DNS resolution to that IP address, as long as the user keeps interacting with the site about every 10, 15 minutes, that IP address will never, that DNS resolution will never be looked up again. And so part of it depends on the TTL of the DNS, part of it depends on the user's patterns. In most cases, if the user's in a session, the DNS lookup is a one-time cost, and then it'll be saved. Another way that you can reduce HTTP requests without reducing content is take the HTTP response and actually embed it in the page itself. And so this is what's called data URLs. Anywhere where you have a URL, you can actually embed a data URL. And so this is the format. Depending on what you're doing, the format's going to change, but typically you base64 encode the response body, and you put it right in where you would have the URL for the source or href, well, not href, script source, yeah, href for link. So you can embed not just images, but scripts, style sheets, any place where you have a URL that the browser fetches. Instead of a URL, you can use the data protocol and embed the response in there exactly. It's best for small response bodies. So small scripts, if you have a script that's under a K, especially under 500 bytes, or a style sheet, same thing with images, under a K, tiny logos, you can just embed them right in the page directly. For images, one problem with that is if you had a bunch of them, they'll make the HTML document grow, and typically HTML documents are not cached. If it's like search results, we don't want that cache. We want you to always get the best, latest search results. So then what you can do is you could put images, if they're background images, you can put them in a style sheet and make the style sheet cacheable. So that's a little trick. And it is true that when you base64 encode the content, that actually makes it about 20% larger. But once you run it through gzip, it's a wash. It doesn't work in old versions of IE. That's a downside. There are workarounds to that, though, if you go online and search. And then the last technique I'm going to talk about is creating CSS sprites. So this is where you have multiple images, typically background images, but you don't have to. You have multiple images, and you concatenate them all together into a single image. Here's a canonical example from my days at Yahoo, where we had all these little icons on the front page, and they used to all be separate HTTP requests, which was a nightmare. And so we created a sprite out of them. Here's what the syntax looks like. You do it with CSS. You specify a background image. And the background position tells, and the width and height tells the browser what part of that image to actually show through the DOM element visible in the page. And also, if you looked at all the separate requests, concatenating or putting the images together in a single image will reduce the overall number of bytes downloaded because you get a reduction in header information, color maps, stuff like that. So I wrote another tool. I've written a lot of tools in this space, so you'll see it mentioned quite a bit. This tool is called SpriteMe. It's a bookmarklet. You can run it inside your site. I don't know if anyone from Space Monkey is on viewing remotely, but I found that one of the recommendations to improve the performance of your site was to create a sprite. So I just opened this bookmarklet. Oh, hey, I'll actually just run it. Okay. Oh, I wonder if I have any embarrassing bookmarks. So here's this SpriteMe one. You can go to spriteme.org and find it. And so you can see it finds all the background images in the page. It's actually kind of a cool tool just to view the images that are being used. So you can see like they're using a background image for these buttons here. And there's a lot of kind of arcane knowledge that goes into creating a sprite. For example, if an image repeats X, then you can't put means repeats horizontally. You can't sprite the images next to each other. You have to stack them vertically on top of each other because otherwise when it repeats, it will repeat the stuff that's on the side. So there's a lot of logic like this. For example, this one is going to be stacked vertically. And so what we can do is we can actually say make sprite. And I teamed up with this other guy that has an image processing web service. And it actually comes back and it's created a sprite out of all those images. Here's what the sprite looks like. Oh, here, let me open it in a new page. So you can see what the sprite looks like. It's concatenated them all together. So it's actually created the sprite, which is kind of a valuable service in itself. So now you could download that image and actually use it. But it's actually changed all the CSS in this page to use that sprite. So right now, this button that used to have a separate image is using the sprite. And so you can go through and you can actually visually see if the use of the sprite is preserving the look and feel of the page. And I've never found any example where it doesn't. And so it's a way to more easily identify what can be sprited in your page, create the sprite, and actually see that sprite being deployed. Okay. All right. So for the first book, that's all I really wanted to dive into with slides, unless there are any other questions about GZIP, CDN, expires header, making scripts and style sheets external versus inline, reducing DNS lookups, minification and obfuscation, e-tags.
So there were a couple of questions, Steve, that came in on the doc. So rather than go through the process of putting them up on the screen, I'll just read a couple of them to you so that you can handle them. So one's been answered on the async tag. Second, what are the advantages, disadvantages of embedding SVG code inline rather than through an IMG tag? Is one method better than the other? And then the second was, what do you think about using Apache module mod page speed instead of doing these things manually?
Oh, yeah. Okay, so the first question was inlining the SVG versus using an image tag. If you, so making a separate HTTP request is going to have overhead. Inlining it in the page is going to make the document bigger. So it depends a bit on the website and the usage patterns. So if it's a site like My Yahoo, where people go, where the typical user session is one page view, then you might want to just inline it, because it doesn't matter if that document is kind of bigger or not, because people aren't downloading it over and over and over again. If the typical usage pattern is 5 or 10 page views, then it might be better to download that as a separate resource that can be cached, so that the next time the user comes back, they can pull it out of cache and not have any of the overhead at all. So that's kind of general advice about inlining versus making something external. It also depends on the revisitation rates. If users often come back, if half the users come back on a daily basis, then they'll have that thing in their cache. If users typically come back once every 20 or 30 days, they probably won't have anything in the cache, so you might want to inline it versus making it external. Inlining it will make it appear faster. External will make it the page faster next time. And the other question was about using mod page speed. We're going to talk about that at the end. It turns out a lot of these things you don't have to do manually. You can use these web accelerator products. So I'll talk a little bit about those and the pros and cons. So if there's nothing else about book 1, here's book 2. And here's where I wanted to get into, and again, I don't want to go through these one by one. Oh, and I had a lot of great contributing authors to this one. I don't want to go through these one by one. If people have any questions about them, let me know. But I did want to talk about script loading, because that's a bulk of what the research behind this book was about. And we had a question about that before. And so, a lot of times when I'm at conferences and stuff, or I'm out bowling, people will come up and they'll ask me, I know you've never seen my website, but in general, what's the #1 thing that do you think is slowing my website down that I can fix? And the answer is always the same as JavaScript. Whenever anyone comes up, even though I've never looked at their site, I can tell them, with 98% certainty that the place they really need to focus on to make their website faster is JavaScript. So why is that? It's because scripts, and we saw this before with Gazillion, scripts have this blocking pattern. So in old browsers, they would actually block everything in the page, not just rendering, but also downloading. In newer browsers, starting with IE8, Firefox 3, Chrome 3, Safari 4, so IE6 and 7 is still having a terrible user experience when it comes to scripts. For these newer ones, they finally added asynchronous script loading. Or parallel script loading. So even though the browser can't render anything in the page, it still starts downloading the other resources in the page. So that's good. And that's called speculative parsing. It doesn't actually parse the rest of the HTML looking for how to build the DOM. It parses it just looking for the tags that cause resource downloads. IMG, iframe, link, script. And then it does the speculative downloading. But they only look a certain amount ahead, and there might be other conditions that cause them to stop. So like in this case, where I have 2 scripts followed by an iframe, an image, and a style sheet, the style sheet got downloaded in parallel with the scripts, but the image and iframe didn't for some unknown reason. So even though we have, I actually think this loading scripts in parallel with other stuff in the page is the best performance optimization browsers have made, even beyond the improvements to the speed of their JVMs. But it's still not perfect. So, and yet JavaScript is really, really important. The impact it has on websites is pretty significant. It's probably the longest pole in the tent, at least I think so. Here's just a back of the envelope test I did where I took the Alexa Top 100 and I ran them the normal way, and then I disabled JavaScript. And they got 30% faster with JavaScript disabled. So it's hard to think of one other single thing that accounts for 30% of the page load time of your site. And to make matters worse, this is a chart from the HTTP archive. The amount of JavaScript on websites is growing faster than any other resource type. So one thing to do to pay attention to that you can do to fix the JavaScript impact on your page is to acknowledge that most of the JavaScript you're downloading in your page that's blocking rendering from happening isn't actually used in the page, at least not initially. So here, this is about 6 months old, looking at the Alexa top 10. There's a tool I have that tells in PageSpeed, the PageSpeed browser plugin, it tells you how much of the JavaScript was actually executed, what percentage of functions. And we can see that for these top 10 sites, they had an average of 230K JavaScript downloaded, but only 30% of the functions in that code were actually executed before the onload event. And so that's significant because any of the code that you don't need until after onload, maybe it's stuff for DHTML, XHR, AJAX behavior, like clicking on a link to compose a message or something like that, requires JavaScript. Any of that stuff you could lazy load after the onload event. So that's one of the rules in the book is split the initial payload. Figure out which of your JavaScript you actually need. If 50% or more of the JavaScript that you're incurring, that you're downloading in the initial page load isn't used, try to pull that out and load it after the onload event so the user gets that rendering to happen as soon as possible. You can use this tool in PageSpeed that lists the functions to get a suggestion for which code you could break out. But the scripts that you are loading in the page, you still want to load those as asynchronously as possible. So this ties to the question we had earlier. When scripts first started coming out, people would put them in the head. And we already saw that causes really bad problems, especially in IE 6 and 7. It blocks all other downloads. Even in IE 8 and 9, scripts will block images from downloading. So you can imagine images are actually one of the most visible things in the page that tell the user the page is loading. And those are blocked if you have any scripts in the head, even in IE 8 and 9. The scripts are actually downloaded sequentially. They're not downloaded in parallel in IE 6 and 7. And of course, all the rendering in the page is blocked, not just during the download, but during parse and execution as well. So if you have hundreds of K, we saw that the average for the Alexa top 10 was over 200K of JavaScript. That can be pretty significant, especially if you're on a smaller profile device, like a mobile device. So then in my 2007 book, I said, move them as low in the page as possible. So the benefit of that is, if they're below everything else, all the other downloads in the page, even in IE 6 and 7, will be prioritized higher than that. They'll happen sooner than that. So it won't block other downloads. But the scripts themselves, if you have multiple scripts, will still be downloaded sequentially in IE 6 and 7. And since they're at the bottom of the page, it won't block rendering during download. But when those scripts are parsed and executed, the page is going to lock up because there's only one thread in the browser. And if that thread is busy parsing and executing scripts, it can't respond to any clicks or any other code that's trying to paint the DOM. So in 2009, I wrote the book and started evangelizing this asynchronous pattern, which I would say Google Analytics has really made kind of the industry standard pattern. So there's a bunch of different ways, and I go over 6 or 8 ways in the book, but this is the most typical way that you'll see a script loaded asynchronously. You create document.createElement script, set the source, and then insert that into the page. This is a pretty safe way to do it if you own the page and you know it has a head. If you're doing it as the third-party script, there's some better techniques to use. But you can see it's pretty short. It's not as brief as just saying script source equals blah, but it's pretty short. And the benefit of this is it doesn't block any other downloads in the page. In all browsers, including IE 6 and 7, it will download scripts in parallel with each other and with other resources in the page. But when those scripts return to the browser, it's still going to lock any rendering or any responsiveness in the browser while those scripts are being parsed and executed. And so that's pretty significant. And that's highlighted by this hack, I think it's a very elegant hack, but it's a hack nonetheless, done by the Gmail team for Gmail Mobile, where they had a bunch of JavaScript in the page, and it was for some feature that wasn't part of loading and rendering the page. It was for something like composing a mail, an email, or resorting the mail folder or something, I don't know what. And it was a fairly significant amount of JavaScript, you know, a couple 100K, let's say. And so what they did was they used some of these asynchronous techniques, but then what would happen is when the script arrived on the phone, even though it was loaded asynchronously, it would lock up the browser, it would lock up Gmail. Even though the user was trying to scroll or click a link, nothing would happen because the browser had downloaded this code asynchronously, so that was beautiful, it didn't block rendering. But when the payload arrived, it still took a significant amount of time for the device to parse and execute that amount of JavaScript. So instead, they could try a different technique, which is don't download the JavaScript until the user invokes that feature, compose an email. When the user clicks that, then I'll download a script. Really? Like, I want to download 200K of JavaScript when the user is waiting for a feature to pop up over a carrier network? No, I don't want to do that. I want to get, I'm not certain the user is going to invoke this feature, but if they do, I want that JavaScript to be resident on the device. But in case they don't click that feature, I don't want to incur the overhead of parse and execution of that code because it's, especially on a small device, going to lock up the UI thread. So they came up with this hack, which is to embed the JavaScript and wrap it with comments so that it's not parsed and executed. So you can get the bytes on the device, but not incur locking up the UI thread. And so then if the user does click that feature, all you need to do is find that script element in the page, extract the text property, remove the comments, and eval the code. And like I said, this is really, really great for JavaScript that you want to get resident, but you're not sure you're actually going to need it. Because now what happens when the user invokes the feature, you only incur the cost of eval. You don't incur the cost of download. Now, eval is evil, I agree with Doug. If you're evaling someone else's code, that's a huge security risk. This is code that you've authored, so you can trust it. And the performance implications of doing eval versus the normal script tag are single-digit percentages, so it's not a performance issue either. So this is really important, but it's a pretty hard hack to get your head around. So I tried to make that easier. I created this JavaScript loader called Control.js. It's open source. You can go to controljs.org and download it. This is used by the Washington Post. Some other big companies are using it as part of their web acceleration framework. And I took this different approach. Two main things I wanted to have happen was I wanted a script loader that could be loaded asynchronously itself, so it didn't block the page itself. And I wanted to do the asynchronous script loading in markup, not in code, to make it easier for people to get on board. So the key is for scripts, you change the type from text script to text CJS. That will cause the browser to ignore it. And you change the source attribute to Control.js source. And this works for another benefit is the async and defer attributes that are part of HTML5 don't work for inline scripts. So often you'll have an external script and then some inline script that uses those symbols. Well, now if you use async for the other one, what are you going to do with your inline code? You have a race condition. So this lets you put all of those together. So it will load external scripts asynchronously, but preserve the execution order between external scripts and inline scripts. And then if you want this added behavior like Gmail wanted of not executing the code until sometime in the future, you could just say Control.js execute equals false, and then later when the user clicks on that feature, you can say execute that script and give the script name. So yeah, that's getting a fair amount of usage. And then I wanted to really quick, since mobile is so big, talk about some mobile best practices. I'm going to try to fly through this really quick. So reduce HTTP requests is still really big. We talked about ways of doing that, sprites and data URIs, inlining stuff. And now with CSS3, the nice thing about mobile is the browsers are newer. We don't have IE 6 and 7 anchoring us down to old techniques. So we can use these CSS3 techniques that used to produce additional HTTP requests, and now instead we can just use CSS3 like border radius and box shadow. Canvas and SVG, again, we can draw things without having to incur a download. Responsive images is important. There's no, although they're working on it, there's no built-in solution for this, so you have to use something else. But the idea is, if I've got a really big image for my desktop, I don't want to download that to a browser that has a tiny screen. It's a pain in the neck to manually create different sizes for all your images and encode those different URLs into the mobile version of the site. So instead we want something that's called responsive images, where something on your server or browser will do that resizing automatically, so that you only download the bytes that you need, making the mobile experience faster and also reducing the data consumption, bandwidth consumption on mobile devices for people who are paying. My favorite is this one from James Pierce that used to be called Tiny Source. He's over at Facebook now, but when he got employed by Sentia, they took it over and now they call it Sentia IO Source, where all you do is you preface your image URL with source.sentia.io. And what happens is when the request goes through their reverse proxy, they look at the user agent and they can figure out 90% of the time, 95% of the time, the screen size for the device for the browser that the user is coming from, and they can resize the image appropriately. They use Device Atlas, another creation from James, to do that user agent classification. And they also support domain sharding. There are also some client-side solutions. There's some links to them. I'm not a huge fan of those because typically that means you're going to have to download and parse and execute some JavaScript before the images can start being requested, and yet images give the user the most visual feedback in the page. So anything that delays the start of an image request, I'm not a huge fan of. App cache is great for working offline. I'm not going to go over this too much. It has a lot of challenges. Here's how it works. The challenges are anything that uses an app cache manifest, the HTML document itself is cached. If anything in the manifest 404s, then nothing in the manifest is cached. You're limited to 5 meg, which isn't bad. And this is just a dev complication. If you change any of the resources in the manifest, you have to make sure to rev the manifest itself. Otherwise, the browser won't look for it. And local storage is another solution, much simpler than for getting things in the cache on the client longer. It's much simpler API, set item, get item. And in all popular browsers, it's supported. You have 5 meg. In most cases, and people are using that for cache. I wrote this blog post where both Bing and Google for mobile were doing it. And really quick, the way it would work is if you did a Google search on mobile, the response was about 100K. And it included all of this inline JavaScript and CSS. But what happened is once that page was done loading on your phone, there was an extra loop of JavaScript that would go over and write all of those blocks of JavaScript into local storage. And it would also set a cookie, and these complex hashes are identify which modules have been written to this user's local storage. So now the next time you do a search, that cookie goes up to the server, to the Google server, and the Google server says, okay, well, I have to construct your search result page. I need to include this module. Oh, you already have it as evidenced by the cookie. I need to include this module of CSS. Oh, you already have it. And the end result is it cuts that 100K payload down to about 10K. So it can be very significant. And the nice thing about local storage and app cache is it's a cache that's reserved for you. Other websites can affect how your resources get pushed out of there. Okay, part 4, performance tools. So if you're working on the desktop, the number one thing you want to try is webpagetest.org. This is an open source project. You don't need to install anything. You don't even need to have a mobile phone. It supports Chrome, Firefox, IE, 6, 7, 8, 9, 10. It has, because it's all open source, people have volunteered to spin up instances in all of these geographic locations, including in China behind the firewall. So you can try loading any URL you want from all of these locations in a lot of different browsers as well as mobile devices. It's really powerful. The downside, you're not downloading it over a carrier network. You don't know what the hardware profile is. The URL you type in has to be publicly available. So if you're working on some private beta, you can't do that. A lot of companies, I would guess hundreds of companies, because this project has been out for a long time, have private instances of web page test. I know at Google we do. And so it's a great, great tool for doing performance testing and analysis. We'll use it a lot in a second. Another tool that I use all the time on the desktop is Chrome DevTools. We used that just a minute ago. Firefox and Opera and Safari have similar tools. I find Chrome's to be kind of at the leading edge. So I've switched over. I use that all the time now. PageSpeed, the plugin, is a way of loading a page and analyzing it according to a lot of these performance best practices. And it tells you which of the performance best practices you're doing well and which ones you need to do better. HTTP Archive is a project that I run where we crawl 300,000 right now, 300,000 of the world's top URLs. And it's good for a lot of stats about the web, and also it's likely that your website is already in here being tracked. So it's a way of getting a history of your website's construction profile over time. Specifically for mobile, there's this thing called MobiTest that was created by a company called Blaze.io that just got acquired by Akamai. I mentioned a lot of M&A activity going on in this space. LogNormal got acquired by Sosta. And they open source this, so this is actually the software that's running inside WebPageTest. So if you go to WebPageTest, you can already take advantage of running stuff on mobile devices. But if you go to the original MobiTest site, they have more tablets, a wider variety of devices that you can run against. So it's worth checking out. You can type in a URL. One of the folks here at Startup U are Retail Me Not. So I just ran it last night and typed in the URL, and it gave me a picture of what it looks like. And if I click on these links, I can get a waterfall chart. I can get a page speed report from it. Again, similar to WebPageTest, this is nice, but it's running in some geographic location that might not be where I want to run it from. It's not using the carrier network that I care about. The URL has to be public. So a lot of times what I do if I want to get past those impediments is I'll start up a Wi-Fi hotspot on my laptop running TCP dump, and then I'll connect my mobile device to that so that everything I do on my mobile device is being tracked by TCP dump. And then when I'm done, TCP dump will produce a PCAP file. Unfortunately, none of the performance tools understand a PCAP file. They understand HAR files. And so this tool, PCAP perf, will convert a PCAP file to a HAR file. And once you have a HAR file, you can run a lot of tools that will produce from a HAR file a waterfall chart or a page speed report. So that's really handy. And then if I want to see things over a carrier network, I have to fall back to bookmarklets. So I created this Uber bookmarklet that has a bunch of other bookmarklets within it, because installing bookmarklets on mobile phones is really a pain in the neck. So you can install this one bookmarklet and you'll get all these other ones, YSlow and Firebug Lite. One that I use to look at local storage for that other blog post I call Storager, and it tells you what's happening in local storage. And it's kind of hard to do a lot of debugging on these tiny screens. So I also created this service called JDrop, which a lot of the bookmarklets are integrated with, and it will allow you to upload the performance data that you have up to the website And then you can go in and log in, and all the data you uploaded from your phone is there. So in the case of that local storage use by Bing and Google Search, I can go in here, and on a bigger screen, I can search for the modules of JavaScript and CSS and see what they look like. Oh, and another one, just to get simple page load times, is this one load timer that I created. You can go to loadtimer.org and type in one or more URLs, and it will load it in an iframe. Very simplistic, but it lets you get some numbers over whatever network your phone is currently using. Okay, and then I think this was the last thing I was going to talk about. We had a question before about mod page speed. So it turns out that as this space, this WPO space has matured, people have realized that a lot of these optimizations are a pain in the neck to implement manually. And so they've created tools to automatically apply the fixes. It works kind of like a transcoder or a router that sits between your user and your web server. So the first example is this one, mod page speed. Mod PageSpeed is an Apache module. You install it, and a lot of the things that PageSpeed will identify that you're doing wrong in your site, mod PageSpeed will automatically fix up. So if you're using Apache, you'll construct your HTML, and then before it departs the server, it will run through this mod PageSpeed fix up, and mod PageSpeed will do things like it sees that you have 3 scripts in a row, and it will concatenate them, save them to disk, and replace those 3 script tags with a single script tag. So a lot of stuff like that. If you don't have a far future expires header, it will add a far future expires header for your resources, and then, but also put a fingerprint in there. So if the resource ever changes, they can change the URL so the user will get an update. Those kind of fixes are done by mod PageSpeed as well as these other services I'm going to run through. Torbit is another one, a local company. I mentioned them. They also do run measurements. They also run an accelerator service. Strangeloop has been around for a while. They do really good work. They have a great blog. I think they might have more advanced acceleration than anyone else out there, a good focus on mobile. Cloudflare does performance optimization as well as other stuff like security, DDoS help, so you can look at what they have. Yoda is out of Boston and China. They're kind of newer to the scene. I don't know if their acceleration stuff is that mature yet, but they're working on it. Aptimize, a company from New Zealand, got acquired by Riverbed, so if you have any affiliation there, they have a product offering. So you can use those accelerator services. The one thing is that they're always going to be a level behind of what's on the cutting edge. So for example, I don't think any of them can make your scripts load asynchronously. That's a very complex thing to do if agnostic to any knowledge of what the JavaScript is doing, what the website is doing. And so I think that for a lot of the kind of rote, tedious things like adding an expires header and a fingerprint, concatenating scripts, these services are a great way to go. Mod PageSpeed is free. It's just an Apache module. But I think it's still really important for the developers for your website to understand what's going on, why these optimizations are important, how they might break the site, and how those developers can apply the latest optimizations that aren't in these accelerators to the website to get the biggest bang for the buck. So that's it for slides. Speed matters. Make sure you have some metrics in place. Focus, if you care about speed of the user experience, you got to focus on the front end, especially JavaScript. There's a lot of best practices out there, and there's a lot of tools, both manual tools you can use to diagnose and profile, and automation tools. So avail yourself to those. And that's it. Thank you. And there's the URL again. Okay, so now it's almost noon, but I would suggest we power through, if that's okay. And we go into this last part, which is looking at some of the sites from people who are here today, not here physically, potentially. So there were a bunch of URLs that I tried, and I got a login prompt or a placeholder page, so I didn't analyze those. Of the URLs I got from the attendees, these were the ones that actually seemed to have like a real content page behind them. And so I analyzed them in web page test. If you go to this URL at the bottom, I should have done a shorthand one of those, you'll see a list of all of them. I sucked out some of the high-level metrics here, and there are 4 sites that seem to be kind of the most challenged when it comes to performance. This isn't a negative thing. This is a hugely positive thing because there's a huge opportunity. If you're doing well now, you can easily make these sites twice as fast, and so think about how well you're going to do then. And not surprisingly, we see that there's a pretty high correlation between these slower speeds and the number of requests and the total transfer size of the website. So that first rule still holds true. Try to reduce the number of HTTP requests as much as possible. So let's look really quick at each one of these. And I'm going to do that live in the browser. Okay, boom, boom, boom. Here we go. Let me get rid of these guys. Okay, so here's that URL for the results that I mentioned to you. So one of them was Copious. I have them memorized in alphabetical order. Okay, so here's Copious. Let's go to that one. All right, so here's what a web page test results page looks like. It doesn't do everything for you. Typically what I do is I run something in web page test, and then I'll go, and if I have deeper questions, I'll run it live inside of Chrome, and I'll look at the network chart, and I'll look at the page speed report. I usually run 3 loads, and web page test, will automatically take the median one. So here it ran first view means empty cache, repeat view means full cache. So I mostly look at the first view, and run 2 was the one that was in the median. So we can go down here. We have the typical waterfall chart, but I always tell it to record video. I guess let me talk about that really quick to show you how I launch these tests. So I'll go in here and I'll say like that. IE8 is the default. I use IE9 now because I think it has a better larger representation. I'll typically do 3. Sometimes I'll just do first view, but here I left it first view and repeat view. I'll leave it as DSL. They're using DummyNet to simulate different network speeds. I leave it as DSL, but then I go into this advanced tab and I say save response bodies. This is so that later, if I come back and look at this and someone goes, I don't know why there was a request for this script or this image, we can actually look at the response body of the HTML document and see what was in there. And then I go over here to video, and I say capture video. And then I just say start test. So let's go back to the results I generated last night for Copious. And because I turned on video, I can go to this film strip view. This is where I always start because I really feel like I was alluded to before in the slide deck that it's not just the raw numbers, a 10-second page load time, a 8-second, a 12-second. It's also what did the user experience. And so here we can see, for example, it's not that bad, but the user sees a blank screen for about 2.5 seconds before something starts rendering. And that stuff that renders is not really that engaging. It's not filling that much of the page. And it's not until way down here at 9 seconds that that the user is getting more of a representation that the page is ready to interact with. So I want to look at these 2 points. I want to look at right here where the rendering started at 3 seconds. How come it didn't start sooner? One thing that's cool, if you watch this red line below, that red line corresponds to the time right here. So as I slide this over, the red line moves. So if I want to see what was happening in the network, I can go right to where the first rendering occurred and see what is happening there. Now it turns out that this was actually when any rendering started, the green line is start render. And so it's pretty easy to see the thing that's blocking rendering is either this CSS file or this JavaScript file. because we know that nothing below a script tag or a style sheet will be rendered until that script and style sheet are done downloading, being parsed, and applied to the page. And so we could ask ourselves, well, why did these take so long? In this case, we notice that these are coming from ajaxgoogleapis.com. The little lock sign tells us that it's the HTTPS version. And if we look and click on this, we can get more detail. Oh, I have to go to the other view. This is not the view that breaks it down by network, but we can see visually a bulk of that download is this kind of purplish part, which is SSL negotiation. Over a second of SSL negotiation, which is kind of strange because the page itself is not HTTPS. And so what's hardwired into this page are they're requesting the HTTPS versions of these of jQuery off of Google Ajax APIs, and they don't have to. You don't have to request the HTTPS version. In fact, it's kind of interesting. They're using a protocol-less requests for most of their scripts, and if they did that for these scripts, then they wouldn't have this second delay for the SSL negotiation. So that's, would move these two things. It would move them so they would finish about way back here. So if that's what's blocking rendering, that would help. It could be that this is also the one, so why is this taking so long? This is from Typekit, so that's a little unfortunate. That Typekit is giving them custom fonts. And it's not that big, it's 84K. This just looks like a slow response. I don't know why. 2 seconds to download 84K, that's really slow. Over a DSL connection in IE9. So anyway, we could look at more downloads. We could debug it live and try to see, does it typically take that long? Do we get any errors if we use the HTTP version of these resources? But that's what's blocking rendering for 3 seconds. And then we can see, if we scroll all the way over here, the red line is almost where it should be. We can see that the problem is this one. And if we open this URL, sure enough, we know what it's going to look like. This is that background image, right? And so that's why the page is predominantly white until the very end, because it's not until this request finishes that the rest of the page can be painted. So a couple things. Why did this start so late? So why is it taking so long? One reason is it's 200K. Could it be optimized? I don't know. We could look at that. The other reason is it's starting really late. It's not starting until 3 seconds into the page. And that's because it's in a style that's in one of these style sheets. Now my guess is, I could have looked but I didn't, that this is a style that's applied to the body or to some major DOM element in the page. I would inline this rule, either in a style block inline in the page or on the element itself. And that way, as soon as the HTML document got parsed up here, it would recognize that it needs this background image and it would start downloading it. Instead, the logic of what the background images are that are going to be needed is captured in this file that's taking 2 seconds to download. And so making the browser aware of that beforehand would shave 3 seconds off this site. I mentioned that I couldn't see the SSL negotiation time. There's this other waterfall chart here, which is a little different view. That other view we just had was by MIME type, which I enjoy more. This one is more about network connection. And so sure enough, if we go up here and click on this, I'm still not seeing it. Oh, I have to do it in the browser. Is that right? But it's showing the SSL negotiation. Oh, here it is right here, 1.2 seconds. And then we also see that even though most of the rendering gets done around 12 or 13 seconds, the page takes another 5 seconds, and that's for all of these custom fonts. I don't know if they're being used in the page, but if they could be downloaded after the onload, that's important. So that's copious. Maybe if they have any questions, they could enter them. I'm going to close this. We'll go back here and we'll go to the next one, which I think was alphabetically MindSumo. Okay, MindSumo, here we go. Boom. Okay, so we see the high-level information is taking 14, 15 seconds for window onload. I didn't talk about speed index. It basically tells you the average time that it takes for a pixel to render in the page. And so if it's very high, that's bad. What we like is we like the average pixel to render in a very low time. So here we're seeing that, so kind of like 50% of the pixels aren't rendered at 10 seconds, or only 50% of them are rendered at 10 seconds. So the median run is run 2. We can go there and look at the film strip view. Now this is really bad. The page is blank for 9 seconds. Okay, why is that? Let's slide that over, and then we'll go down and we'll look at the red line. Okay, first of all, the HTML document is taking a hugely long time, 10 seconds. So the nice thing is they're using document flush, I would guess. So they're pushing down enough packets of the HTML document that the browser can start parsing it and issuing HTTP requests. But the whole thing itself is taking 10 seconds just for the HTML document. So you're never going to get a page load time less than that. So that's something to investigate. The thing that's pushing out the rendering looks like this, but that's an image. So it must be this JavaScript file that then has some processing after it, unless there's another JavaScript file loader later. No, I don't see any ones. These are JavaScript files, but they get downloaded after the render. So this is the only thing I see that would block rendering that is happening before the rendering starts. So we would want to figure out, why is that starting so late? Is there a way that we could speed it up? It's taking 3 seconds to download. It's 170K. Is it compressed? Excuse me. Content encoding. Wow. It's not compressed. So it's 170K uncompressed. That would be more like 50K if they compressed it. So that would probably cut this down, by 50 or 75%. So they should turn on compression for that. Now, what else? Okay, so then we don't get a lot of rendering until this happens. Here, I can go to 1 second and get more granularity. 0.1 second. So all of a sudden, this stuff pops in. So you can see there's a big visual change between here and here. At this point, at 10 seconds, users might feel the page was more ready. And that was gated on some images, it looks like, that I don't know why they started downloading so late. So I would try to find which of these images. I think it's this. There's one here called Linen. And it's included in a style sheet, but I don't know why it gets applied so late. So again, I would inline that rule for this background image that really completes the page and makes the user feel like it's ready for interaction. Let's see, I had some notes too that I'm not going to be able to read. Let's see. For yeah, okay, so for Copious, I hit all of them. Yeah, MindSumo is doing document flush, that's good. Why did the JavaScript start late? One of the image that pushes out the onload is 480K. My guess is that could be reduced. In fact, when I ran page speed on the site, it said it could by optimizing the images losslessly, that means the quality doesn't degrade, 600K of image downloaded could be eliminated. So that would be a good thing to do. Okay, let's look. Yeah, question.
So we actually work on MindSumo. So the main question that I have is basically, it seems like that HTML document is what's really holding us back. It's a disaster that it takes us 9 seconds to render the first thing on the site, right? So what are some strategies we can handle that?
So it's actually not the HTML document that's blocking rendering, because you can see the HTML document doesn't finish till 10 seconds, but rendering actually starts at 9.3. So if we slide this over, well, in fact, it coincides with the green line, we can see it's not the HTML document that's blocking rendering, because it actually doesn't finish until after the rendering has started. So that's not what it is. We want to find the thing to the left of this bar that comes up as close to the bar as possible that we know is a blocker. Images don't block rendering. Scripts and style sheets block rendering. So if we go through here, green is, what did I say? Scripts and style sheets, yeah. Green is style sheets, orange is image. The style sheets are finishing pretty early before the rendering. So I don't think it's the style sheets. Here's a script that doesn't finish until half a second before the rendering. And it's a pretty big script, 170K. My guess is, and we know rendering won't start until this is done downloading, being parsed and executed. And my guess is it doesn't finish downloading here, so the earliest rendering could start is here. The reason it's bumped out another 500 milliseconds is that's probably how long it's taking for the JavaScript to run.
Okay.
So this is what's blocking your rendering from starting earlier.
Okay. So in terms of strategy, so then one of the things that I'm also concerned about is the fact that the script itself starts getting downloaded at the 5-second mark.
Yeah.
So up until then, we're not even processing any part of the script, so that's also a disaster, right? So
Yeah.
what might be some reasons for that?
Well, this is kind of weird. Okay, so the page is taking a long time.
Is it because these all 8 connections are gone?
Well, the thing that's really, okay, so one thing is, even for the first byte, it's taking 3 seconds. So that should really be like 200 or 300 milliseconds. So it's about 10 times longer than it should be.
For the first
Byte of the HTML document. So, I talked before about the performance golden rule, focus on the front end, not the back end. You guys are the anomaly. Your back end is actually taking a really long time. Even if we ignore the last byte, just the first byte is 3 of 12 seconds. So it's about 25%. It's pretty high. So there's something that's happening on the back end. You're doing a lot of database lookups, RPCs, something like that. You got to figure out why. And then, the cool thing, so then this is actually kind of weird, and it's something to do with the behavior of IE9, that it happens this late, because I looked at the HTML document, and that script is actually pretty high in the page. Like, I think it's the second, third, fourth resource that's requested in the page. It's requested before all of these images. If we ran this same site, and you could do it right now with web page test, instead of picking IE9, pick Chrome. And you'll see a very different waterfall chart. You'll see that this script actually starts downloading much sooner. So the good news is, as far as the impact of this script, you're going to have better performance, a faster page in Chrome. Now, right now I think IE9 and Chrome are pretty much similar. I think Chrome's a little ahead of IE9. But I would bet that this bad sequence of downloads also happens in other versions of IE. So if you add up all the versions of IE, it's probably your biggest browser. Maybe not, and so it's less of a concern for you, but if it is, the good news is in other browsers it's probably not this bad. The bad news is in probably the dominant browser, there's something funky going on. So certainly one thing you could do is you could load it asynchronously. And that would probably kick off the request sooner, and it would also not block rendering.
Okay. So yeah, because I think the key thing is we looked at GT metrics to basically compare between YSlow and page speed, right? So and page speed gave us a really good rating, whereas YSlow definitely had some issues, and so this is really helpful to see. So I guess in order to sort of
You have long periods of silence for the remote viewers.
Oh,
Use the mic heavily.
yeah. Sorry about that.
There you go.
Yep.
So just to summarize then, for us, the focus will be, one, making sure that our backend is not taking quite so long, making sure that we're not doing too many database lookups right when we start the page. And then the second thing that we'll focus on is maybe we'll try and load this application.js asynchronously so that it block rendering and also in the start.
Yeah.
Okay.
And then some of the, like this one, this is 11, it takes 11 seconds to download this image. It's 480K. I would bet that that's one of the ones reported by, oh, well, you know what? They actually run page speed as part of this test, so we can go to page speed here, and optimize images is a red. I didn't look. Do you know what that, oh, here it is.
Yeah, I know what that image is actually. I know
Yeah.
what that image is.
So it says it could reduce it by 470K losslessly,
Okay.
which seems like, well, here it says that's a 97% reduction.
Right. Okay. So that's probably something to look for.
Yeah. Should we do more? Should we do another website, or are you guys pretty much done?
Chance you can take a look at ours?
Yeah, which one is yours?
It's, for some reason it's not on your list. It's mediaspike.com.
Okay. Oh, it's here.
Oh. Sorry. So our site's mediaspike.com.
Yeah, so that's why I didn't do it, because it didn't seem like this was the main site.
That's www.mediaspike.com. Interesting.
Cool.
Yeah.
Okay. All right, so we'll run this guy like we did before. But we'll go back and we'll do a live analysis while we're waiting for this to finish. And I'm going to go back and I'm just going to do first view so it finishes quicker. There we go. Okay, so let's go back here. We'll open this guy. And I'm going to do a shift reload so that it ignores the cache. One thing that this won't highlight is there's obviously a redirect going on between www.mediaspike.com and /intro. So here I just reloaded the page we ended up on, but for people going to the main website, they're going to have an extra redirect, which is going to be kind of a pain.
So it's basically it's redirecting you between if you're a logged in user or the intro.
Okay, there we go. I do that because if later some JavaScript issues a request, then all of this network waterfall chart will slide over anyway. That's why I did that. Okay, so what do we see here? The back end took a fair amount of time. It took 1.5 seconds, so that's kind of surprising, especially because we avoided the redirect. So that would have been, getting the page started would have been even worse. It looks like none of these requests are taking very long. All the bars are pretty small. The colors reflect MIME types, so blue is HTML, orange is JavaScript. I think green is CSS, yeah. So those are pretty good. Oh, and let's see, I forget what blue is. DOM content loaded, and this is probably, oh, the window on load event. That's interesting. So the one thing we can't really see here is when rendering started. We know it happened after here. It probably happened somewhere before that. We can look at that in web page test later. Let's see, so I see a lot of things happening in parallel. That's good. The purple is images. And yeah, so overall, I mean, the page took 3 seconds to load. That's not bad. What are these? Some XML. Yeah, so these aren't affecting the onload event. They're happening later, though. So overall, the page doesn't look, that bad, especially compared to mine, Sumo. He's not listening. Okay, so let's run page speed on it and see what it says. Yeah, so there's no large priority items. Leverage browser caching. Yeah, these resources don't have a really long cache time. So nothing is found here. So now let's go over here. The main thing I want to do when I go over here is I want to look at the impact on rendering. So speed index will give us a thumbnail. 5700 isn't great, it's not bad. So now if we go to film strip view, oh, see here, it's a different story. Why did it take so long here? Oh, well, one is we have the, oh no, we don't have the redirect. Ah, that's interesting. Okay, so yeah, it's blank for a long time. Now, the fact that we didn't experience 9 seconds when we just did it live, but we did here, we could maybe ignore that, but you know, we all know there's hiccups in the internet. So
89 versus Chrome.
it could be that. The thing that is weird here is how long this SSL negotiation takes. And again, like, I don't think you have to download this script off Google using HTTPS. So since the main page is not HTTPS, if you did HTTP here, all of this negotiation wouldn't have happened. Same thing with these here. Where are these coming from?
Hey, Steve.
Yeah?
One of the questions that came in the doc was about HTTPS, and is there a way to limit HTTPS negotiation time? If you're serving anything over HTTPS, can you cap that or somehow bound the time from when it's requested to when it completes? Can you shut it off? Can you talk about that?
Yeah. So let's do this, and then let's talk about SSL in general. And so, you know, here's the start render time. And so it looks like these scripts are all blocking that. So we don't know why things seem to take longer, but we do see that there's a critical path. And, you know, I didn't have time to talk about it here, but I have a lot of videos and blog posts about single point of failure. And so, you know, when you have a critical path that can basically bring the site down, I mean, here the site is blank for 10 seconds, which is not a good thing. You want to avoid having critical path items, and you especially want to reduce the number of items that are on the critical path that produce a single point of failure. And so what we would see is all 6 of these scripts, I think this is a script as well, are single point of failures on the critical path. And so if any one of these takes a long time, it's going to push out the rendering of the page. So the main thing here is to try to load all of these scripts asynchronously, if there's a way to do that. And even if you can't load them all asynchronously, if you have 6 single points of failure and you reduce that to 2, if all of them have an equal probability of bringing the site down, you've cut your chances of having an outage by 2/3. So that's a good thing to do. Yeah, but this looks pretty good. There's a lot of parallel downloads. I might do some domain sharding here. These aren't taking that long, but what we see happening is a little bit of this stair-step pattern. It's not quite as visible because the responses are fast, but we're seeing that we're getting 6 requests off, but these are waiting until one of these 6 connections is freed up. And so if you had another domain to do domain sharding across, that would probably be good. So then there was a general question about SSL. You can't really cap it. You know, one thing is don't do HTTPS unless you need to. So if the main page is HTTPS, then everything else has to be HTTPS. Otherwise, you'll get security warnings for most, if not all, of your users.
Sometimes it is, and sometimes it isn't, which is why those scripts are HTTPS. So.
Yeah. One thing you'll see in the docs for Google AJAX APIs, I guess that's just coming off google.com, is at least for Google AJAX APIs, the documentation actually says to use a protocol-less URL. So you would just say //www.google.com/JSAPI. And the nice thing about that is if the page is HTTPS, it will do it on HTTPS. If the page is HTTP, it will do it on HTTP. So basically strip out hardwiring HTTPS into the page for those resources. So that's one way that you can reduce the impact of HTTPS is by only doing it when you need to do it. If you don't own the resources, so for example, in this case, this is coming off Google. I don't know why the negotiation is taking so long. If you own the servers, there are a lot of inefficiencies in HTTPS. People think HTTPS is just going to be significantly slower by the nature of it, and that's not true. The problem is that a lot of the encryption algorithms and other aspects of HTTPS were written 10 or 15 years ago, and the code just hasn't been optimized. So fortunately at Google, we have a guy who lives and breathes HTTPS optimization. His name is Adam Langley, and he's taking care of that for us, although this request to www.google.com wouldn't support that claim. But nevertheless, he is a guru, and if you search for him, he did a talk at Velocity 2 years ago that was really good, and you can get on board with some of these for the, if you host your own HTTPS resources, optimizations that you can deploy to make HTTPS faster.
If you want to do one more, there was a request that came in, and I think it was one of the ones you'd identified in your chart, Pokey, P-O-K-K-I.
Yeah. Did you have any other questions about MediaSpike?
No, I think actually one of the other things where a lot of these scripts are going to be all around the internet, so I think you had some of them already cached, and maybe explain some of the speed on the other tab.
No, this one was done with an empty cache.
No, when you loaded it directly into page.
Oh, yeah, that's right. Yeah, so that would have happened. Yeah. Okay, so then let's look at Pokey. Let's see. My eyes have gone really downhill. Oh, here it is. Since the last time I was here. I have reading glasses now. Okay, so yeah, we see, the load time is 15 seconds. What's more alarming is the speed index is really high. It's twice as high as the site we just looked at. It's at 12,000. In fact, I've never seen a speed index number that high. So the median run was run 2. Let's go to the film strip view. So one thing we see is the page is blank until 8 seconds. So that's pretty bad. So that's going to be the green line. Let's look. What we want to do is we want to find what's the thing to the left of this green line butting up against it that's pushing that green line out. That's a blocking resource. Purple is images. Those aren't a blocking resource. Although this one does butt up against a line, but there's no way an image can block rendering. So instead what we know it is it's this resource right here. It's a JavaScript file. And my guess is I noticed that this one follows this one. I wouldn't be surprised if this one is somehow requesting this one, or if somehow they're using some kind of script loader that here I see require.js. Some of the script loaders are trying to help you load scripts, and they actually make it worse. In order to make sure that there aren't any race conditions for undefined symbols, they'll force the scripts to load down sequentially, and that's worse than what all modern browsers do today, which is they'll download all the scripts in parallel, but they'll still make sure that they're executed in the order dictated by the page, by the web developer. So I would guess, in fact, if I look at these oranges, this one doesn't start until after this one doesn't start until after that one, and this one doesn't start until after that one. I would guess that there's some kind of script loader or something that's not native to the browser that is loading these scripts sequentially. And that's really bad because scripts are what block the entire page from rendering. And if we can load those in parallel, we want to do it. What's even better is to load them asynchronously so they don't block rendering. But here they're being loaded sequentially. So we're back to the behavior of IE 6 and 7 now, even though we're in IE 9. So that's pretty bad here. That's why the speed index is so high. For about half of the page load time, there's nothing on the screen. And then what else do we see? Let's see. This is going on. Oh, this was an interesting one. We noticed that even though the onload event hasn't fired yet, here's onload out at 15 seconds, they're repainting this image that takes up a bulk of the page and is a pretty big image. So, before, wow, you can even see how big it is. It actually takes multiple seconds to render. And these are these big images down here, these 4 images, like slide 1, slide 2. Wait, no, that's not it. Where are they? I don't see them now. Slide 1, slide 2, slide 3, slide 4. I think that was this one, wasn't it? Glasses, glasses. Yeah, I thought it was, the names were slides. Oh no, that was for Vungle. So I don't know what's doing it, but I would guess that, you know, through JavaScript, they have different kind of screenshots that they rotate through. And I think that's a fine feature. It's just that you don't want to do that in the middle of the page loading because it's probably going to result in another HTTP request. And the page isn't ready anyway. And so you're delaying the parts of the page that haven't rendered yet for something that is already visible. So it's just giving the page a sense of being even less ready than it already is. And let's see, what else can we see here? Yeah, a lot of these requests are taking a long time. 300K of image. I would bet there's a fair amount of optimization that can go on. And what's pushing out the onload? It looks like oh yeah, there's just these images that are very late. I would guess, I can't see the domain names. It doesn't look like they're doing domain sharding. I see pokey.hs.llnwd a lot. And so we might be running into the 6 connection max per host name limit here. And so we're getting a little bit of a stair-step pattern here, you know, especially once we reach this point. You know, it's like there's a block of them, and then we get another block of them, then we get another block of them, then we get another block of them. And so it might be that domain sharding would be a good choice here. And then we can go back and look at what PageSpeed said. Yeah, so they talk about optimizing images, could reduce it by 90K. It's not as much as I thought. And there's not a lot of expires headers. And then let me see what else was in my notes. Yeah, domain sharding would be good. There are some, oh yeah, those big images take 10 seconds or more to download. And don't refresh that main image until after the page is loaded. So I think what I'm going to do, so are there still questions in the document to go through? Rick, you want to give me a thumbs up or? Good? Okay. So feel free to send me an email. Try out webpagetest.org if you have any questions about your site's performance. Feel free to email me if you have any follow-up questions. There's a web performance blog aggregator called perfplanet.com. If you want to stay on top of the blog posts that I have and about 50 other experts in this space, add that to your RSS reader. It's not that much, maybe 2 or 3 blog posts a day. But it's a way to stay on top of the latest debates about RUM versus synthetic and these web performance optimizations. And that's it. Thanks.